Hello there. Now that you're familiar with how to construct a frequency table, it's time to move on to a subset of frequency tables. These are called interval frequency tables. Interval because we allow for a range of values instead of having a row for each individual value. There are two reasons why we might choose an interval table over an individual table. The first is if we have a theoretical reason for doing so. So let's say we wanted to see how many students in our class had A's, B's, C's, D's, and F's. By setting up intervals that are 10 digits wide, we can see at a glance how many students fall into the A category, B category, C category, etc. This can be really useful in helping us understand the data based on theory. The second reason we choose to use intervals over giving each value its own row is when we have a lot of data. There are two reasons behind this. The first is that when you have a lot of data, you can end up with a lot of rows because there's the possibility for a lot of values. Not always, because it depends on your data and what type of data you're collecting, but you could end up with a lot of rows. The second is that you might end up in a spot where you have a lot of rows with a frequency of 0. And when you have a lot of rows with a frequency 0, you end up in a spot where you have difficulty seeing your data for the trees, or the forest for the trees, to follow the saying more correctly. Let's take a look at the data set I've prepared to see why this is. So we see here we have this out of 100. We have 100 missing, but we have 99, 98, 97 is missing, 95 and 94, 91, and 90 are all missing. That's a whole bunch of missing values, and if we did an individual frequency table, we'd end up with a whole bunch of empty rows. Not to mention that even with these duplicates, we'd end up with a table that fills at least a whole page, and if we had double this many, let's say some students did extremely poorly, we could end up with a frequency table that extends into 2 or 3 pages. So, now that we know why we might use an interval, let's talk about how we choose the interval. So we could use one based on theory, and we could do that here. We would end up with 4 different rows, one from 60 to 70, 70 to 80, 80 to 90, 90 to 100. And that could be useful. However, to give us a little bit more practice, I'm going to go with interval 5. I'm going to choose interval 5 because that's reasonable for this data set, because 5 is not too far from the square root of 30. And the square root of our number of values is one heuristic we use in choosing the width of our intervals. Or rather, in the number of our intervals, I should say. The width is related to the number, but they are separate entities. And so I've decided on width 5. Now I need to know where to start. Before I can start, I need to know that there are 2 rules when it comes to our intervals. First, the interval cannot overlap. So no overlapping. If we go, let's do interval of 3. If we had 61, 62, 63, and then we did, next one was 62, 63, and 64, we have this overlapping. Our 62 and 63 are being counted in 2 places. That makes error, well, one, it makes it more difficult to read, and the reason for that is because we've introduced error into our table, so we want to avoid that. The second reason is we can't have gaps, so no gaps. So if we went 61, 62, 63, and then we went 65, 66, 67, we'd have a gap. Now there may not be any values of 64 or 65, but even if they aren't there, it's important for them to be present in our intervals because the table tells us about the data and what it looks like. If we have gaps in it, we can assume there's nothing there, but we can't know that, and it makes it difficult to interpret, especially for someone who wasn't there to create it. And since graphs are often used in sharing data with others, it makes sense to create them in a way that people who pick them up for the first time can understand them easily. So we've decided on width of 5, and we know that we can't overlap and we can't have gaps. If we were to create a third rule, is that all data needs to be inside a gap or an interval. Yeah, so all data needs an interval. So that means we could start at 60 as the lowest number our first interval could start at. Since we're dealing with multiples of 5, I'm going to start on a multiple of 5 with 60. And I'm going to go up. So I've got 60, 61, 62, 63, and 64. That's going to be my first interval. So I have 60 through 64. My next would be 65 through 69. Again, an interval of 5, and starting at 65 because it can't overlap. 64 can't belong in both intervals. Then we have 70 through 74, 75 through 79, 80 through 84, 85 through 89, 90 through 94, and 95 through 99. There we go. That's pretty good. Now that we have our intervals laid out, we're going to go ahead and calculate our frequencies. We're going to go back to our data. As you've probably already noticed, mine is in numeric order. This makes it easy for me to see what belongs in each of my intervals. Some of my professors gave me this type of data all scrambled. Let me tell you, it is a whole lot easier to unscramble it and then check your frequencies than to go through it each time looking for numbers that fall inside your frequency. It's also less prone to errors if you sort it out beforehand. And an error at this stage means you have to start over on your chart, especially if you're doing it by hand like I am or like my professors made me do. So save yourself the time, sort these out before you start counting up your frequencies, and it'll save you a lot of headache later. So first interval was 60 to 64. I have one value. So that interval has frequency 1. 65 to 69. Let's see. That would begin here and here. This interval has frequency 4. 70 to 74. That would start here, ends here. Again, frequency 1. 75 to 79. Well, that begins here. 79 is here. This is too high. Again, frequency 4. 80 to 84. Let's see. There's 80. There's 84. That's going to give us frequency 5. 85 to 89. There's 85. Oh, there's 89. That's 4. This is 5. 4 and 5 is 9. That's frequency 9. 90 to 94. Start here. And here, that's frequency 2. And 95 to 99, the end of it. There and there. That gives us frequency 4 again. Next, we have our percent frequency. Our percent frequency is essentially a relative frequency, except it's been converted into a percentage. Let me show you what I mean. Since we know we have 30 values here, or a total frequency of 30, we're going to take our frequency of this first interval, 1, divide it by 30, just like we would for our relative frequency, which gives us 0.033. I'm going to multiply this by 100 to give me the percentage I'm looking for, 3.33%. This applies to all of them. I could just leave it as 0.033 if I wanted a relative frequency column. However, the percent frequency is more common on an interval frequency table, so I'm going to stick with the percentages for the rest of them. Alrighty, but I am going to put these in a box together so I don't get confused as I go in and continue adding to the rest of these columns. All right, so we had 4 divided by 30 was equal to 0.133. So that times 100 would be 13.3%. 1 comes back. This gives us 3.33 again. And really, I shouldn't have, because if we're dealing with 0.033, I'm moving it over, I get 3.3. So let's scratch out this 3 just because that's where the 2 decimals we've kept, or the 3 decimals we've kept, end up being. All right, we've got 4 again, so that gives us another 13.3%. 5 divided by 30 is equal to 16.7%, yes. Took me a moment to convert that in my head. Let's see, 9 divided by 30 is equal to 0.3, so this is just 30%. 2, we haven't had that before. 2 divided by 30 is equal to 0.067, so 6.7%. And 4 comes back again for another 13.3%. Now, the next column is our upper real limit. The upper real limit invites a discussion of apparent versus real limits. So when we're talking over here about our interval, our upper and lower bounds, the 95 and the 99, or the 90 and the 94, those are our apparent limits. Those are what we believe bounds those values or bounds those intervals. However, that's not quite the truth. We also have real limits. Real limits exist because when we're dealing with mathematics, we round numbers. So when we're talking about our upper real limit, everything up to 99.5 would be rounded down to 99. Thus, 99.5 is the upper real limit of this interval. For 94, it would be 94.5, 89.5 here, 84.5, 79.5, 74.5, 69.5, and 64.5. These are upper real limits. If I grab another color, I can show you that we also have lower real limits. I just didn't include those in this table. We'll put them over here because we would round up, say for 95, we would round everything up to 94.5 would get rounded up to 95 and included in this interval. So we would have 89.5, 84.5, 79.5, 74.5, 69.5, 64.5, and 59.5. So we have lower and upper real limits for each of our intervals, and that is how you calculate them. You realize that we round numbers, and based on the rules of roundings, 5 and above or 4 and under, we make our upper and lower real limits. Next, we have our cumulative frequency column. This is exactly like the cumulative frequency column that we discussed on the individual frequency table. You need a more in-depth view on that. You can go back and look at that video. But we have 1 at or below this interval. Then we take the next interval. 1 plus 4 is 5. So we have 5 scores at or below 69, the apparent limit of this. But technically, it would be below 69.5, the upper real limit of this interval. 5 and 1 is 6. 6 and 4 is 10. 10 and 5 is 15. 15 and 9 is 24. 24 and 2 is 26. And 26 and 4 is 30. You'll notice I did a pretty good job starting out. We have here, here, here. Then I'm starting to get off. And then I got back on. Be very careful as you're building these frequency tables by hand. Just getting off by a little bit can make it pretty difficult to figure out what value belongs to what. And it's not as bad as making a mistake back here, but it can still cost you a lot of time. Alrighty. Next, we have our last column, cumulative percent frequency. This is just like our relative frequency, except we have converted it into a percentage, just like you saw in our last video. We converted cumulative relative frequency into a percentage. So here we go. We have, let's see. We have there, yeah. So up here from our percent frequency, we have 3.3%. And I'm going to use a calculator because some of these numbers are weird. I chose them because you'll see a lot of simpler examples in class, but it helps to see an example with some weird numbers that aren't as intuitive to work with as you prepare for exams where you might have to do this. So 3.3% plus the 13.3 is equal to 16.6. Let's make sure we're going across. Yeah. Started that first one too low. 16.6 plus another 3.3 is equal to 19.9. And I don't round when I'm adding these up. I may be slightly off at the top, regardless of if I round or not. But by not rounding, I keep these numbers more exact to what the frequency is, or the percentage frequency is, than if I rounded. Let's see. Plus another 13.3%. Whoops. I didn't hit the plus sign. Plus 19.9 plus 13.3 is equal to 33.2. And again, all of these are percentages. So just throw these signs in to make it clearer. 33.2 plus 16.7% is equal to 49.9%. Plus 30% is equal to 79.9%. Plus 6.7% is equal to 86.6%. Plus 13.3% is equal to 99.9%. So just like our relative frequency, or rather our cumulative relative frequency is supposed to add to 1, our cumulative percentage frequency is supposed to add to 100%. You can see that I have an error of about an error of 0.1, in that due to my choice in not rounding and the odd numbers I chose to work with, I have 0.1 off of what I should be. However, I'm not going to introduce that error in below because that would involve these numbers being less reflective of the percentage of people with scores at or below the appropriate level, or below the linked level. So there you go. That's a relative frequency table, cumulative relative frequency table with intervals. I hope you have learned a little bit about why we use intervals, how they're useful, and how to construct them, and that this is all very simple if you just keep your lines in order. I did a very good job at the beginning, lost a bit here, lost a bit here. It would be helped by drawing lines across. I know that may take you some time, and you may not have that on a test, or you may not care to do that. Perhaps some ruled paper would help. But there you go. Let me know if you have any questions about this, And I'll see you next time with the presentation on interpolation, which is the step that comes after our interval frequency table, because this tells us the percentages of people at these scores, or rather at the top of these scores. What if we have a score like 77? We know that it's 4 up, so 1, 2, 3, 4. We know that it's below 33.2%, but where is it exactly below that? We know it's between our 33.2 and our 19.9, but where exactly is it in between those two percentages? So we'll cover that next time.